everyone, I'm Won Lee. We studied statistical properties of beta 1 hat last time. Today, statistical properties of y hat. Very similar process, and let's see what is statistical properties of y hat. From sample x1, y1, x2, y2, xn, yn paired data, n many paired data, that's a sample, the estimates beta 0 hat and beta 1 hat are calculated, and regression line is yi hat equal beta 0 hat plus beta 1 hat xi, I from 1 to n. This is a fitted estimated line. So this is y hat equal to beta 0 hat, beta 1 hat, xi, right? Here, yi hat is called fitted value of xi. Okay, when x is xi, the value on the line is called fitted value. If beta 0 hat and beta 1 hat are expressed as random variables, as we studied this one, then yi hat equal to beta 0 hat, random variable here, beta 1 hat, random variable, xi, then this is also random variable. I think it is important to, explain this kind of a material, regression analysis material. Otherwise, a little, confusing, and students cannot follow the explanation. yi hat is used for two purposes. First, it is an estimator of expectation of yi. Expectation of yi what? We say the model yi equal to beta 0 plus beta 1 xi plus epsilon I. The mean of epsilon is 0. So mean of yi, expected value of yi is this one. That's it. Second, it can be used as predicted value for prediction for a given value x0. Subscript 0 means given value, certain value. So when y hat is an estimator for the mean of yi, its distribution is as follows, this way. yi hat follows normal distribution with the mean of yi variance sigma square times 1 over n plus this term. Okay? You don't have to memorize this kind of thing. You better just understand. Okay? When y hat is used for prediction purposes, prediction is a little ambiguous thing rather than estimation. So prediction purposes y0 hat, y0 hat, y0, what is it? y0 at x is x0 given, okay, given. Then mean is, its mean, y0 hat follows normal distribution, beta 0 plus beta 1 x0, variance sigma square, 1 plus same thing. The variance will be bigger. So prediction is, say, ambiguous, okay? The range of variance will be wider. Okay, example continued. Simple example, we've seen X number of employees, 1, 2, 3, 4, 5 at the time. At that value, sales amount Y, 1, 1, 2, 2, 4. It was a simple example. First, estimation of average sales for number of employees of 4. Okay, X equal to 4. We want to estimate the average sales estimate. Then we need to use single star distribution, this distribution for estimator for mean. Okay, so confidence interval for this average sales, okay, is y hat plus minus t degrees of freedom 4, and the value of t is point tail area is 0.025, because we want to use what, 95% confidence interval. Okay, sigma hat, of course, instead of a sigma, we use sigma hat times square root 1 over 5 plus this term here. So the result 2.7, this is what? Fitted value 2.7 plus minus 3.182 value of t here, and the sigma hat is 0.6055 times 1 over 5 plus this one. So the result is 1.6445, 3.7555. What is it? About the 2.1, the range width of a confidence interval. Prediction case, we want to predict sales at number of employee equal to 4. Okay? Well, say next month, because it is a prediction. Next month, I want to use number of employee 4 here. Then what is the sales? We want to get 95% confidence interval. In this case, since it pertains to prediction, we will use the formula double star distribution. This distribution. What is the difference? Difference is only this. Because I say it is a prediction is more ambiguous. Therefore, the 95% confidence interval will be y hat plus minus t 0.025 with the degrees of freedom 4 sigma hat. Sigma hat is this one times square root 1 plus 1 over 5 plus this term. Okay? So the confidence interval will be what? The width is 4.3, almost double of this term. So we use this for prediction. Usually when you get a result from computer statistics program, then you will get this one, this value. Okay, I will show you later with an example. Okay, it is not difficult, it is just simple, I think. Okay, this is it today. Thank you.